This is example 2, part A only, on page 4 in your lesson 4.2 packet. So here we go. We're only going to work on, for today, the vertical asymptotes for the graphs. So what we do for the vertical asymptote is we focus on the denominator and try to figure out how this denominator could equal 0. Because if that denominator did equal 0, then the function would fail to exist at that point. So whatever x value produces 0 will be bad, and therefore that's where the asymptote will be. All right? And some graphs like this one will actually have 2 asymptotes, because we're going to factor it using techniques from earlier this year to x plus 3 and x plus 4. And for this to equal 0, x would either equal -3 or x would equal -4. Therefore, if you actually plotted this on your graphing calculator, you're going to see that there are 2 asymptotes, one at -3 and one at -4, and the function will do some odd things, in between those asymptotes, but that's where they are. You should be able to find those on your calculator, just to see how the graph behaves at -3 and -4. Also, if you put this in your graphing calculator and you try to trace to -3 or -4, it should tell you that y does not exist at either one of those x values, further confirming that's where the asymptotes are. Don't worry about part B yet. We'll do that during the next lesson. So we're only focusing for today's lesson on the vertical asymptotes. Next, we're going to move to example 3, part 1 only, step 1 only, the vertical asymptote. So we're going to take the denominator. Remember, the vertical asymptote is all about where the denominator, 3x minus 4, could potentially equal 0. In a problem like this, where you don't have an x squared, you're going to solve by adding 4 to both sides and then dividing by 3, showing us that the vertical asymptote would be at 4/3, which is approximately 1.33. So you'd go over to about 1 1/3. At 1 1/3, that's where the vertical asymptote would be. Again, we're only focusing today on vertical asymptotes. You're going to try it A, step 1 only. Try it 3B, step 1 only. And then let's move to example 5. Another one, vertical asymptotes. Where would the denominator, x squared plus 2x minus 15 equal 0? Well, let's factor it to find out, because we have a quadratic. So I think this one's going to be x plus 5 and x minus 3, meaning that x equals -5 and x equals +3 would be where the asymptotes are. So you'd go to -5, which with this wacky scale would be about right there. And +3, it looks like we're counting by 4s, so that would be about right there. So again, if you would graph this function in your calculator, it's going to be sort of a wild function, but you should clearly see that the function is going to avoid x values of -5 and +3. One more time, you can confirm that by trying to trace to -5 and +3, and you'll see that y does not exist at those values. So that's it for the examples. Hope you understand how to find vertical asymptotes. You have to do step 1, for try it 5, and you'll be done.